Okay, college algebra. Let's continue 2.6, graphing piecewise functions. I always generally give these main steps. You plot your boundary points with open circles. You shade the right one, right being correct, where the equal sign is. And 3, you graph left for less than and right for greater than. Now let's see what that actually means in a problem. You're more likely to see one that's like number 1 or number 2. Number 3 is an extra challenge problem if you want to do it. We won't do it on the notes. So f of x equals -2 if x is less than or equal to 0, or 4 if x is greater than 0. So this boundary point where I switched functions is 0. So I'm going to plug in 0 to both functions. F of 0 equals -2. It's a constant function, so we have 0, -2. So I'm going to plot 0, -2 with an open circle. Do the same thing for 4. F of 0 into the second function. It's also a constant. That's 4, 0, 4. Those are the only boundary points I have when there's two functions. They should always be vertically stacked on top of each other. That's all for now. Step 2 is shade the right side, right being the correct one. How do I know which one it is? Wherever the equal sign is the one that actually gets the value. So that's the -2. So I'll shade the circle with -2. Now, one of these functions, -2, is only for x values to the left of 0, so I can only graph it to the left. 4 is only for x values to the right, so I can only graph it going to the right. Given these are both constant functions, -2 is a horizontal line coming out to the left. 4 is a horizontal line coming out to the right. Now normally you're not going to have a constant function, so that's not the only thing you do. You may use plug-in points. If you're ever not sure though, plug in a point, see which side it is, and connect to the corresponding point. 2 is more likely to be a problem you'll see. F of x equals 2x if x is less than or equal to 2, or -3 if x is greater than or 2. So again, start with your boundary points. F of 2 into the first function. 2 times 2, which is 4, so we have the point 2, 4. Now into the second function, -3x, -3 times 2, it's -6. So you have the point 2, -6. So I'll plot 2, 4 with an open circle, 2, -6, open circle. Which one of these has the equal to sign? It's x is less than or equal to 2, which is the first function, so we shade 2, 4. Let's go to the left. We know that this function, f of x equals 2x, is the slope of 2. It's a rise over run of 2. Normally we would do up 2 and to the right 1, but less than really means I need to be going to the left, so I really need to do the opposite. So I'm going to go down 2 and to the left 1 to find other points. Down 2 over 1. And you don't need a bunch of points to graph this, but I'm going to do it just in case. So since we can't go to the right, this graph only goes to the left, we only graph going to the left. Now, what about on the right side, the -3x? This one is a slope of -3. That would be down 3 and to the right 1. Now because x is greater than 2 here, I can go to the right on this one, so that's the direction I want to go. 1, 2, 3 down, 1 over. And just graph the line. I always think this thing kind of looks like a man pushing a lawnmower. I don't know. But your piecewise functions will usually focus on the constant functions and the linear functions. If there's anything else, it'll be a parent function. You can try number 3. I wouldn't recommend it. I won't put any on the test that are as difficult as number 3, but it's good for your understanding. Now, find the equation of a piecewise function given the following graphs. So if you can go from equation to graph, you should be able to go from graph to equation. Okay, so every piecewise function is always going to start with an f of x equals a brace and then some functions. So again, the first thing I would do is look for the boundary point, the point that is vertically stacked over each other. It looks like that x value is -1. So we have an x is less than -1 and an x is greater than -1. Where's the equal to sign? It's wherever it's filled in. It looks like it's filled in going to the right, which is greater than. So this is greater than or equal to. Let's talk about our functions. The horizontal lines are easy. They're constants. It means it's f of x equals a number wherever the height is. So this is f of x equals 5. That's if the x is greater than or equal to -1, so we know the 5 goes here. The second one has a slope, so we're going to have to find the slope. It looks like we go up 1 over 1, so that's a slope of 1. So we know that there's a 1x, or just an x. It also looks like it's going through the origin, so it looks like our constant would be 0. We don't really need that 1 or the 0, so you can also rewrite this as f of x equals x if x is less than -1, or f of x is 5 if x is greater than or equal to -1. So that's what it would look like to turn the graph into an equation. And one last thing that's on your homework that I don't test over, but it's important that you know what it looks like because it makes a bunch of piecewise functions, is called the greatest integer function. Greatest integer function is outputs the values of the function as the largest integer value the function has taken up to that point. So basically the largest integer value underneath your actual value. So what does that mean? Well, it means if you're at a half, what's the biggest integer under a half? 0. So your function's actually going to output 0. The greatest integer function is denoted by this double bracket on the side. So what does it look like? I think it's easier to see what it looks like with f of x equals 1/2 x. So we know when we plug in 0, we get 0, which is an integer. But what happens when we plug in 1? What's 1/2 of 1? It's 1/2. What's the biggest value, whole number, integer, under that 1/2? It's 0. So even though we plug in 1, we're still at 0. When is it do we finally get to the next integer? When we plug in 2, because half of 2 is 1. So it creates this kind of stair step, where every time you hit a new whole number, you have kind of a piecewise function. You jump to the next stair, because it only outputs whole numbers, so no slants. Same thing going down to negatives. So the question should be, what do numbers in front do? The 1/2 actually, just like it would decrease the slope of a line, it kind of stretches the stairs out. Fractions in front stretch the stairs out. Whole numbers in front will shrink the stairs, because the normal one up here, it just looks normal. It's a 1-to-1, so it's kind of hard to draw. But overall, functionally, it's very similar. It's a steeper staircase. And that's really all for 2.6, and we'll move on to 2.7 next time.